Hello everyone, this is your physics class and today we are going to discuss about wait, I'm wearing mask. Wait, see, this is called a rubber, and if the deforming force applied on it, it will change its shape and size. So you can easily stick to your nose like this. So students, there is a property by virtue of which if the deforming force is applied, it can change its shape and size, and when the deforming force is removed, then it regains its original shape and size, and this property is called elasticity. This property is called elasticity. So what is called elasticity? When the deforming force is applied, then it changes its shape and size, and when the deforming force is removed, it can regain its original shape and size, and this property is called elasticity. So elasticity is the property by virtue of which if deforming force is applied, then we can change its shape and size, and when the deforming force is removed, then it regain its original shape and size, and this property is called elasticity. So students, our new topic is elasticity. So students, in elasticity you have to cover definition of elasticity. Next, see, there is some body which is are called perfectly elastic body, like quartz. In our digital watch we use quartz. We can say it's a perfectly elastic body. So what is called perfect elastic body? If it completely regain its shape and size, if when the deforming force is removed, then it can regain its original shape and size completely, no deformation takes place or permanent deformation. Okay, so it regain its original shape and size, then this is called perfectly elastic body. Remember the name quartz. What? Quartz crystal. Quartz. Second thing, what is called perfectly inelastic body? What is called perfectly inelastic body? Like wet clay, you can form any type of shape. You can give any type of shape with the help of wet clay. Okay, wet clay. Okay, these are called the perfectly plastic body, perfectly inelastic or plastic body. And there is some body like rigid body, which you cannot change its shape and size. So these are called the rigid body. So students, no bodies are perfectly elastic or perfectly rigid. Every body, the property of every body means the elastic property in between these two limits. It's neither perfectly elastic or nor perfectly rigid. Okay. So students, next your topic is Hooke's law. For that you have to know what is called stress. What is called stress? Stress means force by area. So here force means the restoring force. Means, see, this force is called deforming force, by which can deform the body. So applied force is the deforming force, but the internal property by which it can regain its original shape and size, this internal force, okay, by which it can regain its original shape, this force is called restoring force. So student, force means here restoring force by area. So restoring force per unit area is called stress. Student, unit of force is Newton, area meter square. So Newton per meter square means the unit of pressure. So it's nothing but a pressure. You can write pressure. Okay. So Newton per meter square, or you can write Pascal, whatever you want to write. So the unit of stress is the unit of pressure. Number 2 is called strain. Strain means the change of length or change of shape by original shape. Okay, so any change of dimension, by original dimension. Better we can write dimension. Dimension means it may be in area or change in length or volume, whatever. So change of any dimension by original dimension is called strain. Next, very important, Hooke's law. What? Hooke's law. Hooke's law. Hooke's law said stress is directly proportional to strain. And if you write this thing, stress is proportional, then we got, it means stress proportional to strain. If you write this stress proportional to it, you will get 0, because you have to write within elastic limit. What? Within elastic limit. Within elastic limit. So stress is proportional to strain within elastic limit. Within elastic limit, stress is proportional to strain. So stress by strain is equal to constant, and this constant is called modulus of elasticity. Modulus of elasticity. Now students, you tell me, what is the unit of modulus of elasticity? What is the SI unit of modulus of elasticity? Student, if you put the unit stress, the unit of stress is, you know, pressure. So unit of stress is pressure, Newton per meter square. Now think about strain. Any change in dimension by original dimensions. So if you change by length, so it means centimeter. Here original length also centimeter. So centimeter and cancel, there is no unit. So it's a pure ratio. So pure ratio means it has no unit. So Newton per meter square is the SI unit of modulus of elasticity. Okay. So very important Hooke's law. First of all, what is called stress? Stress means restoring force by area. You just pause the video and write it down, and please prepare. Better you say with me, what is called stress? Stress means this restoring force by area, Newton per meter square. Okay. Restoring force means the internal force. Okay. So restoring force by area. And what is called strain? Any change of the dimension by the original dimension. So these are called the strain. And what is called Hooke's law? Stress is proportional to strain within elastic limit. If it is in elastic limit, then you can say stress is proportional to strain. Say 5 times. Stress is proportional to strain. Stress is proportional to strain. Stress is proportional to strain. And stress by strain is called constant. Stress by strain is called constant. Stress by strain is called constant. And this constant name is modulus of elasticity. Modulus of elasticity. And this modulus of elasticity, this modulus, and you know the dimension, also the dimension of the pressure. Modulus of elasticity dimension is the dimension of pressure. Because strain has no dimension, so you can write the dimension of pressure. Okay. Okay. Next, so you know modulus of elasticity, types of modulus of elasticity. So students, we can write the modulus of elasticity. Modulus of elasticity. These are 3 types. Number 1 is called Young's modulus. What? Young's modulus. Number 2 is called bulk modulus. And number 3 is called modulus of rigidity. Young's modulus you can write capital Y. Bulk modulus you can write capital B. And modulus of rigidity we can write eta. What? Eta. Modulus of rigidity is called, we can write eta. So Young's modulus Y, Young's modulus Y, bulk modulus B, rigidity eta. Rigidity eta. Okay. So Young's modulus. Students, suppose you have a wire like this, and the length of the wire is capital L. Capital L is the length of the wire. Now you suppose hanging some weight. Okay. So weight means the mass here with some hook, and the length elongated by delta L. Length elongated by delta L. So this is the original length as it is, and the elongation delta L, change of length delta L. There is a fixed support by which can hanging this string. Okay. Now Young's modulus. Students, we can write y is equal to what is called modulus of velocity? Yes, stress by strain. Stress by strain. So you can write stress by strain. Stress by strain. So just put the value. Stress means force by area. Here strain means change of length by original length. Change of length here delta L and original length is capital L. So by rearranging it we can get y equal to, here force means what? Force means m into g. Force means what? mg. So we can write here force by area into delta L capital L. So in place of force we can write mg into capital L by area means pi r square. See, think r is the radius of the wire. So r is the radius of the wire. Area equal to pi r square into delta L. So y equal to mg capital L pi r square into delta L. Okay, please copy, students. Pause the video and copy. Okay. So this is the Young's modulus. Now you tell me, student, which one is more elastic? Which one more elastic, rubber or steel? Rubber or steel? See, my mask is more elastic, isn't it? How? See, the elastic property of my mask much better than the steel. But according to physics, students, you must say that the modulus of Young's modulus means elastic material, which one is more elastic? So steel is more elastic, students. Yes, steel is more elastic. Steel. Why steel is more elastic? Because, student, if we compare these two, S for steel, formula mg L by delta L into area. Suppose the elongation of steel is delta Ls and take equal length, equal area, equal mass, equal G. You know G is constant for both cases, steel and for rubber. So what about rubber? So Young's modulus for rubber is equal to mg capital L, take same length, by delta L of R into area. Now compare steel by rubber. Okay, so everything I think cancel out, only we get delta LR by delta LS. So student, Young's modulus and delta LS inversely proportional, isn't it? Y and delta LS inversely proportional. So we can write, so you know which one is more elongated for same amount of mass. If you given same amount of weight, then you think rubber more elongated. Rubber the stretching of rubber will be more than the steel. Am I right? If you given same mass, then the stretching of rubber would be more than the steel. So that's why this is greater than 1. So we can write greater than 1 because LR is greater than LS. That is why greater than 1. So we can write Young's modulus of steel is greater than Young's modulus of rubber. Okay. Is it okay? Okay. So our next topic is bulk modulus. Bulk modulus. Students, what is called bulk modulus? Suppose you have a sphere and some pressure given to it, then what happened? The volume will be increased. Okay, then volume will be increased. So student, here bulk modulus B is equal to force by area, which is called pressure. So we can write here pressure in place of stress, and in place of strain, suppose this is the original volume and the change of volume is delta V. This is the original volume, and if pressure released or pressure given to it, if pressure given by outside, then the volume will be decreased by delta V. So student, if pressure given to it, then volume decreasing. If the pressure released, then volume increasing. So volume and pressure, students, inversely proportional. So for bulk modulus you can write minus P and the change of volume by original volume. Change of volume by original volume. So B equal to minus PV by delta V. This is your bulk modulus. Why minus? Because if pressure increases, delta V decreases. If pressure decreases, delta V increases. So student, pressure and volume inversely proportional. That's why minus. Another more important thing, which is very important, what is called compressibility. The reciprocal of bulk modulus is called compressibility. Reciprocal of B. So compressibility K, compressibility K is equal to 1 by bulk modulus. K equal to 1 by bulk modulus. It is reciprocal of bulk modulus. Okay, and one more important thing, that is sharing stress or sharing modulus or modulus of rigidity. So suppose students, think you have a rectangular block like this, okay, and you given a tangential force over it, then what happen? It will bend with some angle, am I right? Theta, this theta, and the transition take place like this. So this is the dotted portion. Okay, so actually I given force, tangential force to it, and the transition takes place like this. So your rectangular block shifted like this. So the elasticity or the stress for theta is, you can write with the help of eta. So eta is equal to force by area, same thing, and the change of dimension here only theta, so we can write theta. That's all. This is called modulus of rigidity. Student, this is our first video of elasticity. Okay, in second video we will discuss about the potential energy per unit volume. Find the potential energy of a stress string per unit volume, and number 2, which is very important, the stress versus strain graph. Okay, thank you for watching.